Good afternoon, all. Today is the third technical session of AICT PARAKH 5th batch. All are requested to please mute yourself during the session. We will open this forum for question and answer after the session. Now, I would like to introduce our today's expert, Engineer Yogendra Asthana. Engineer Yogendra Asthana from Pidilite Industry Limited, Construction Chemical Division, who owns brand Dr. Fixit Rock, Sifi, polyurethane, and have manufacturing and marketing rights of Pagel, Germany specialty routes in India. He has more than 20 years of experience in the industry of construction chemicals and had been involved in the marketing and application of construction chemicals at many large infrastructures, industrial, residential, and commercial projects, and also worked for leading companies in this construction chemical industry. He has vast experience on use of the construction chemical in achieving durable and sustainable structures. Welcome to you, sir. Now over to you, sir. Please take the session, sir.
Thank you. So I'm sharing my screen. Can please allow me to share screen?
Yes, sir. Please share your screen, sir.
I'm not able to share right now. We'll have to give rights.
Permission is already given, sir. Please try again, sir.
No, it's not happening. No, I think there is some gap. I'm not able to share.
Sir, please left and again join in the meeting, sir. Okay. I think there is technical problem, sir.
Okay. No, it's not happening. Expanding.
Yes, sir.
It's not happening.
Wait, sir. I am checking, sir. Sir, PPT is visible, sir?
Yeah, PPT is visible now.
Okay, sir. You can start, sir.
Mhm. So,
Thank you, sir.
good afternoon, friends. So, I'm Yogendra Asthana. So, today we'll speak about some energy efficient waterproofing and insulation composite systems for green buildings. So, green building is now, these days, is a buzzword. A lot of work is going on, energy efficiency, more sustainable constructions, and all those things. So, what is the role of good waterproofing and what kind of insulation composite systems which are waterproofing as well as insulation systems which are there in market, and how they work and how they help in achieving the green building criteria for the structure. We'll have a look on those. We will discuss about those kind of systems. So let's first understand what is this green building. So you all know something about these green buildings. So basically, in very simple language, a green building is something is a building in which conserves natural resources. So in this complete process, in construction of this process, it does not hamper to the natural resources, uses less of water, optimizes use of water, optimizes energy efficiency. Energy demand of the structure, energy demand of the building is so managed that it is optimized, not it is not consuming high amount of energy, then generate less of waste and provides a healthier space. So in this very, in a simple way, it is this is these kind of structures which comply to these parameters. They're called green buildings. They fall in the parameters in the category of green buildings. So it's not just if you see the criteria which we mentioned in our earlier slide. So there are the components like energy efficiency and building material and resources and indoor environmental quality. In these factors, in these criteria, our role is there. So we as a construction chemical company, we somewhere play role in these categories. Uh, how to improve the energy efficiency of the structure and the building material usage, better usage, optimum usage of the different building materials to better durability. And then as a result, indoor environmental quality is improved. It is made more healthier and more habitable. So if we see, I am from Pidilite, so currently working for Pidilite. So Pidilite is a company, you all know about Pidilite in some way or the other. The very famous brand of Pidilite is Fevicol. So we are also, in addition to those kind of adhesives, we are also in construction chemical zone where we manufacture a lot of different materials which help in uh, making more durable structures, making a leak-free structures. Waterproofing materials are there. Then we are also into insulation systems. So we our materials, much of our materials, we are also helping in this green world's green footprint. So we manufacture materials which does not which are more eco-friendly kind of material, and the usage of these materials are for reducing the seepage and leakage into the structure. That's in that way reducing the wastage of water and the damaging effect of water into the structure, and then repair cost and then energy consumed in repairing and all those things. So it is all chain reaction. Then allows to maximize your energy saving goals in this through the buildings, and then negligible environment impact by use of our kind of waterproofing and insulation materials. They are not toxic. They are toxic free ingredients are used in manufacturing of this material. They are environment friendly, and they are certified by certain certifying agencies like GRIHA and IGBC. Then they have reduced or zero carbon footprints. Also, zero plastic footprints. So we are very responsible to our environment. So usage of these materials is done to enhance durability and of the construction for a long-term performance, extended life, and thus ensuring health and comfort of the building occupants. So leading to all, it results into a sustainable structure, which is achieved by making it leak-free as well as heat-free. So leak-free is related to waterproofing and heat-free is related to insulation systems. So these composite combined system, it helps in achieving more healthier and safer environment within the structure for occupants. So making the occupants more happy, more healthy. So now green structures, why this need came up, why it is eminent now that we should go for energy conservation and all those things. According to this, some kind of research, it is found that our climate is, the environmental temperature is increasing day by day. And in last 50 to 30 years, the temperature has increased, the global temperature has increased by 2 degrees Celsius. And if it keeps on increasing by this pace, so by end of this century, the temperature will be 3 to 7 degrees Celsius higher. And we observe that cities are significantly more warmer than the rural areas, the landscape areas or rural areas where. So this difference can range from 4 degree to 7 degrees Celsius, and this is called as urban heat island. Why this is happening? Because there are a lot of concrete jungles, a lot of concrete surfaces are there, roof, pavements, and they are absorbing heat, and this is creating a heat island effect. So, and urbanization is happening in a very fast pace, and it is expected within the next 50 years. So more than 80% of the population will be living in urban areas, or the rural areas will get converted into urban areas because of these developments. So, but that is why it is very eminent how to reduce these kind of heat gain, and a lot of work is going on in this direction. So we will deal into the structures, what we can do, what kind of materials are there which can help in reducing this, reducing the heat absorption in the structures. In a working area, in a typical workspace, or be it a residence, be it a commercial space, anywhere, the heat is absorbed and from the outer environment through sun rays. Then there are heat generation because of electrical equipments and all those machines which are working within the building structures. So you see a person sitting in a room, and there are a lot of systems through which heat is gained into the structure. If you see the Indian climate is more of tropical climate. So we are a tropical country. So it is hot and dry. Most of the part of India is hot and dry, and next is hot and humid. So almost 70% of the area is this kind of area where the heat is very high. In summers, the temperatures are reasonably good, and the structures which gain heat is more of from roofs and walls, window, doors, and roofs. So from these surfaces, almost 85 to 90% of heat gain is happening within the buildings. And how this heat gain contribution is from outer heat absorption as well as inner heat generation also. So we can control to some extent inner heat generation, but we will deal how the outer heat absorption can be reduced. So the outer heat absorption is the source of heat is mainly the solar radiation. How this heat flows into my building? It can flow through a conduction process, like conductivity of building material on which this solar radiation is incident to. It will absorb heat and it will conduct heat inside the structure. Then there is convection. Convection through air movements. A hot air movement, the heat will move from one end to other end. Then there is radiation. The solar radiation incident radiation on the surface. Then surface absorbs heat and conduct it into the structure. So in radiation, this solar radiation, infrared radiation plays the major role. IR plays the major role in the heat on the incident surface, incident heat on the surface. And they contribute almost 55% of the solar radiation. IR or NIR, near infrared, they contribute total about more than 55% of the, so the solar radiation, the heat absorption through these will be very high. And radiation is absorbed by the surface. Roof wall is the major component which absorbs heat. They absorb almost 70 to 75% of the heat because they are made of materials like brick, concrete, other kind of materials which absorb heat. They are not insulated material, insulation material. They absorb heat. And this absorbed heat get converted into heat energy, and that this heat energy gets radiated inside the structure. If we analyze the energy demand of a large structures, different segment wise, if we see the industries, they have 42% of the energy demand, and building structures 33% of the building energy demand. And from buildings, commercial buildings, they are the highest contributor of in the energy demand. So energy, and in this commercial buildings also, HVAC consumes the maximum energy. HVAC, the cooling system, it consumes the maximum energy. In this pie chart, you can see that 55% of the energy is consumed into the HVAC system.
So sir, your slide is not moving. You are talking about pie chart, it is not coming.
It's not coming.
On our screen.
Sorry. I think Pratibha ji, आप कौन से पेज पे हैं? Okay, should I keep saying for changing the slide? I missed it. I thought I am the controller.
It is required, sir. Please say next, sir. I will be there, sir.
Okay, you can.
We are
change
in the second slide. We are in the second slide now. So far, 2 slides you have shown. First slide and the next slide.
Oh,
that is
sir,
now we are seeing green building redefinition.
Sir, this slide is okay.
Yeah, change it to next slide. We have spoken. We have gone up to, I think, change to next slide. Change it to next slide.
This
Can I
slide,
take
sir?
control from here?
Wait, sir. I'm trying, sir. Sir, please try, sir. Sir, please try.
No, I'm not able to change.
Okay, sir. I'm adding here you, sir, as a co-host, sir.
Yeah, I got a notification that I am added as a co-host, but
Could you please try for again sharing the presentation, sir?
no, I'm trying, but it's not happening.
Okay, sir. Could I share again, sir?
Yeah, share it again then, because it's not happening from here.
Okay, sir. Now it's visible, sir?
Shift it to next slide.
Okay, sir.
Next.
Is this
Next.
okay, sir?
Next. Next. Yeah. Okay. Be this the previous one.
Okay, sir.
Okay. Is it visible now to everyone?
Yes, pie chart is visible now.
So I was at a point that commercial building consumes maximum energy in a building segment, and then in commercial buildings, the maximum energy consumption, the demand is consumed, energy demand is from HVAC systems. So almost 55% of the energy consumed in commercial building is into the HVAC segment, segment. So if we improve energy consumption pattern of our HVAC systems, how we manage some kind of energy conservation in this segment, so we will be able to give a good impact into the energy demand of the building. So next slide, please. Okay, so in this energy demand, ECBC, the energy conservation building code, they mention that a building envelope is required, which should have in a structure, a building envelope should have good thermal performance requirement from their walls, roofs, and windows. So this building envelope, which encompasses the outer surface area of the complete structure, we'll see the how with what is called the building envelope. So this is demand or code which says that the thermal envelope should be given, which should have a good efficient property into the energy conservation. So they should have a good insulation property so that and some kind of heat insulation can be achieved. So these code guidelines, they draft the code guidelines, and these code guidelines are mandated by all states to be implemented into their building bylaws. So around 13 states, they have unified these code with their bylaws, but some are still working on it. So in this, they have defined a building into 3 categories. One is ECBC compliant, other one is ECBC plus, the third one is super ECBC. So ECBC is a building which is compliant and gives and achieves up to 20 to 25% of more efficient, energy efficient than a conventional building. The second category is ECBC plus, which is a compliant building and has 30 to 35% more efficient energy consumption than the conventional buildings. And super ECBC have a better rating of 40 to 45% of more efficiency, energy efficiency. So, but the first category, ECBC, the first category is the mandatory. This is the minimum requirement for any commercial or government building which is being constructed nowadays. So this code says that a building of any building of commercial usage and connected to a load of 100 kilowatt or greater and the contract demand of 120 kVA should have to comply this ECBC code and should have a reasonably good building envelope, better HVAC facility, conserved lighting, and electrical motors and renewable energy. So if we see the a building envelope, the outer surface area, this is the IR photograph of different buildings. So in these first three buildings, which are showing a more hot red color, they are consuming a lot of energy and they have absorbed a lot of heat during daytime and they are emitting that heat. So in this IR photograph, first three buildings, we can see that the outer surface area of a structure, they are basically the energy guzzler. They consume a lot of energy. The fourth building is a insulated envelope building.
So once again, you are static.
Which has
once again, your slide is not moving.
Insulated envelope. So we can see the photographs more of towards greener and blue shades. So the energy
your slide is not moving, sir. It will be better if you share your slide because we are not able to only your static.
Next slide, please.
It's fine, sir.
Next slide. This coordination is giving an issue. Okay. No, go to the previous slide, ma'am. The previous one is so this in these photographs, as I was saying, that the first three photographs are more of red. So the IR photograph shows that they are lot of heat generation is happening in these structures. And the fourth photograph is having a insulated envelope. So the heat absorbed on the surface is very less. So the IR photograph shows more milder blue and green zone. So the building envelope, next slide please. So this red line shows the building envelope. So this is the outer face of all the my building structures, which separates my conditioned zone from the unconditioned zone. The zone where I need a conditioned zone, the outer envelope surface is the surface where I should be putting up my insulation system and waterproofing systems. So this red line zone is the surface area, is the surface which will be needing a good application, good system, which achieves by which a leak-free and heat-free zone is achieved inside the conditioned space. So next slide, please. So as we have earlier mentioned, that roofs and walls, they are the major source of heat gain. They are the major surfaces which contribute to the almost 70% of the heat gain or loss. So these are the surfaces which are mandatory to have a good combined system of waterproofing as well as insulation property. So next slide, please. Now, if you see, we have mentioned that the solar radiation is the main source from where the buildings absorb heat, apart from whatever equipments we use inside the structures. The how we can achieve a insulation property on the roof and wall is the condition which we have to work on. Now, there are different kind of systems which either work on solar reflectance or they work on conductance. They reduce the conduction of heat which is absorbed on the surface, and there are some systems which allow the incident rays to reflect back, the heat generating rays to reflect back. They work on solar reflectivity. So the coatings which has a higher solar reflective index, which is called a rating as SRI rating, solar reflectance index, it will have a better reflectance property to reflect the maximum amount of infrared rays back into the environment. So the lesser amount of heat will be absorbed on the surface. The SRI value, the systems which have SRI value greater than 100, so normally white surfaces, they have SRI 100%. They have SRI value 100, and super bright white or the slightly glossy white will have higher reflectance. So there are some kind of coating materials available these days, which when coated on the surfaces, it will give more of reflectance on the surface and less heat absorption. Please. So as I said, and in solar radiation, almost more than 50% of the component is NIR, near infrared rays, and these are the rays which are the main contributors into the heat generation, heat absorption, they contribute maximum in this heat generation. So reflectance of these IR rays will help in reducing the surface temperature, lesser heat absorption on the surface. So higher SRI value coatings or systems, if provided on the surfaces, will give that kind of property by which lesser heat will be absorbed by virtue of more of IR rays reflected back into the environment. Next slide, please. Now, this was something which is coated on the surface, top surface, and working on the principle of reflectance. The second systems are which work on the principle of conductance. So there are some insulating materials which is provided, which is sandwiched between different layers, so that the heat which is absorbed, it is not conducted into the structures. So as per the National Building Code, overdeck system means the system which is provided above roof. They are more effective in the tropical zone where our country is lies against against the system which are provided under deck below the roof surfaces. So you must be knowing a lot of systems are there, and old conventional systems of insulation work. We used to give some thermocol sheet below, or false ceiling is given, false ceiling is provided, and this is also above this false ceiling thermocol sheets are there. These kind of different systems were provided. These are called underdeck system. The systems which is provided above roof slabs, RCCs provided above RCC slab, they are called overdeck system. And as per NBC, they are more effective in our kind of countries, the tropical countries. Next slide, please. So in this, if you see, we have seen the systems based on reflectance. There are two kinds of systems based on reflectance and based on conductance: overdeck system and underdeck system. So the conventionally, there were some systems which were conventionally being used in past also, like some lime surki was given used while preparing the substrate above the roofing in olden times. Then there were inverted earthen pitches, small pitches, or kullad, we call it in northern India, we call it kullad, or the wooden pitches were inverted wooden pitches were placed and then filled it back with cement mortar. Because of these air gaps in between, this insulation property was achieved. Then in some areas, you can see, you would have seen that China mosaic is given, broken China mosaic is given. They work on reflectance. All these are conventional systems. So now for reflectance, there are high-end coatings which with high SRI value, they are provided on the top surfaces. And for conductance, there are different kind of material. Extruded polystyrene boards are there, PU foam boards are there, spray PU foams are there, foam concretes are there, vermiculite is there, expanded clay materials are there, glass wool is there. So a lot of different materials are there now available. Apart from this, some in smaller structure, even if you go for a greenscaping on the top of terraces, they also give that cooling effect. Green spacing means green vegetation provided on the top surface, like landscape surface, landscape terraces or terrace garden, or landscape non-tower podium areas. They also give some sort of insulation property because of this wet soil and green plantation on top. They also give insulation property. So next slide, please. So we have seen different categories of insulation, how it can be done. We are not touching the underdeck system because it is now obsolete. A lot of as per building code also, they are allowing more of overdeck waterproofing, these insulation systems. Now we will take one by one different materials, how they perform. First, we will take up the reflectance material, the material which are SRI coating or high albedo coating, different names it is called as SRI coatings, high SRI coatings, high solar reflective coatings, or albedo coatings, high albedo coatings. So they work on reflectance. So they reflect back into the environment the heat generating IR rays. So by virtue of it, what will happen? The surface will absorb lesser of heat. If the surface has absorbed less heat, so it will conduct less heat into the structure below. So by virtue of this, some insulation effect is achieved. But it all depends on the surface area, the volume below the structure, and in what kind of zone my building is lying. It is more of in the hot, humid area or hot, dry area, or it is in the temperate zone like Bangalore or some areas like that. So the effect will be different in different areas. So next slide, please. But the only main point in this is the coating should have reflectance index above 100%. So ideally it should be somewhere close to 104 to 105. So these kind of coatings are available these days. So they allow. So this is how it works. If we the first picture is showing surface temperature of 47 degrees Celsius, and that surface is not coated with SRI coating. So the surface temperature is 47 degrees Celsius. The second surface is coated with a SRI coating, and it is showing a surface temperature of 32 degrees Celsius. So we can see that the surface temperature is reduced by about 15%. So this 15% reduction on the surface temperature will allow the surface to absorb less heat because it is exposed to a lesser heat on the surface. So it will absorb lesser heat, and by virtue of it, it will dissipate less heat inside my structure. So it will give better comfort in the space which is below. Next slide, please. So in this picture, it is showing how it works. So it reflects back the IR rays. So very less amount of heat will be absorbed by the coated surface, and so less heat will flow into my structure. Next. And if you say what kind of material we have in this range from Pidilite, they are roof seal top coat, new coat, and hydroshield PUD. So and for GI sheeting, where for kind of industries and all, on GI sheeting there is cool roof coating. So these are all acrylic coating, and they normally come in white color. So in some spaces you can get it tinted also, but as you go for a darker tinting, as you start tinting to a darker side, the reflective index will get reduced. So if you want to achieve insulation property, surface insulation property, so you have to keep it white. And once coated, you have to maintain, keep it clean, because if dust is accumulated on that, so it will, the reflectance property will get reduced. So it has to be kept clean. Normally, the simple cleaning can have a long side effect on insulation property. All these materials are green label, green material, and certified by GRIHA. GRIHA is our own Indian Council for Green Rating, and it is equivalent to the International Rating Association LEED. So GRIHA, the full form of GRIHA is Green Rating for Integrated Habitat Assessment, and it is equivalent to, this is Indian version of International LEED, which is Leadership in Energy and Environment Design. So these materials are approved and certified by GRIHA. Next, please. So those were high reflectance SRI coating. Now we'll come with to a material which work on a conductance. Insulation, which is given on the top surfaces above my roof surfaces or wall surfaces to give a better thermal efficiency to my surfaces. So the unit K value is a very basically a K value is thermal conductivity of a material. So the low K value material, so low thermal conductivity. So the kind of material which are available in construction zone, which are used in construction of buildings, or used in insulation giving insulation to the buildings, they fall in 2-3 categories. So the first category is called as pattern roll category. In this, there fiberglass is there, mineral wool is there, like rock wool and slag wool are there, plastic fibers are there, or some natural fibers are also used. In older times, natural fibers were used, like husk material, which were mixed with soil, and they were a thick layer was given on the top surfaces to give insulation properly. So they were also used. Then there is a foam board or rigid foam board category. Here we have foam concrete panels, we have polystyrene boards, we have expanded polystyrene and extruded polystyrene boards. Expanded polystyrene boards are basically the extruded one they have better thermal efficiency than EPS systems, but EPS systems are more solid. XPS systems are also solid, but they are a costlier version. Then polyurethane foam panels are there, and polyurethane foams are also there. Spray polyurethane foams are also there. Then the third category is sprayed foam system. Again, in the sprayed foam systems are this polyurethane foam, which I mentioned here also. Then there are foam concrete also, foam concrete which is sprayed. Then there are vermiculite, they are expanded clay systems. So different materials are available. So how different materials are suitable for different kind of usages, we'll see which material has a better K value, better insulation property. We'll see in the next slide. So please next. So before we reach out to understanding the different materials, we understand the different terminologies which we will be using. The R value, K value, and U value. These are the three values, three units which will be normally used in understanding the thermal efficiency or thermal conductivity of the different materials, and they are regularly used in this system design. So R value is basically thermal resistance. It is the ability of material to resist heat flow, and its unit is meter square Kelvin per watt. So, and R is basically, R value is T upon K. T is the thickness of material and K is the thermal conductivity of the material. And U value is just reciprocal of R value, and it is called as thermal conductance, and is the ability of the material to conduct heat. So if there are different layers of different materials, so U factor will be achieved, will be calculated as 1 by R1, R2, R3, R4, R plus. So all these materials, the R value of all materials will be added and taken a reciprocal of that. Next slide. So as we mentioned, different materials in different categories. So mineral wools, they have a K value, thermal conductivity value of 0.042. Whereas expanded polystyrene boards, they have a K value of 0.038. So the lower the K value, the better is the insulation efficiency of the material. Then XPS board, they have K value of 0.030, and PU foam, they have PU polyurethanes, they have the K value of 0.025. So in this, we can see that the polyurethanes are more efficient in giving thermal efficiency insulation to the structure against the mineral wool, EPS, and XPS. All these are used, but the most efficient material is polyurethane foams, polyurethanes. So next slide, please. So as per ECBC, they have defined the requirement of a commercial building, which is on for different usage. Like here we see on the first slide, it is 24-hour use building, like hospitals, hotels, call centers, where it will be used 24 hours. It will be habitated 24 hours. Then the U value requirement in a composite climate, here if you see most of the part is hot and dry or warm and humid. So the U value requirement for these in these buildings will be 0.281 U value, and R value will be 3.5. Similarly, for daytime use building, day use building, where it is not 24 hours, it is morning 9 to 5, 9 to 6 usage is there. There the U value requirement will be 409 and R 2.1. Similarly, for walls, a 24 hours use building will have a requirement in hot and dry or warm and humid climate. U value requirement will be 0.44 and R value 2.1. Similarly, based on these values, the different materials are designed. So what kind of thickness of, and to achieve this R value, we have seen one formula. R is T upon K, the thermal conductance. Thermal conductance of material we have seen for different material, where we saw that polyethylene foam has the lowest K value. So by virtue of it, if we want to achieve R value of 2.1, so the polyethylene foam will require the minimum thickness to achieve that kind of U value, R value, and the material which has higher K value will require lesser, higher thickness of material to achieve that kind of insulation demand, as which is laid down by ECVC. So next slide, please. So this is in this slide we have mentioned that for a R value requirement of 3.5, which we have seen for roofs in a 24-hour use building, ECBC guideline says that roofs should have 3.5 of R value. To achieve this, if we use different materials, in your screen you can see that different materials are there. Brick bed coba is there, brick is there, foam concrete, aerated blocks are there, autoclave blocks are there. Then there are different mineral wools, wood wool is there, glass wool is there, EPS is there. So the thickness and the bottom number is showing the thickness, how much thickness is required to achieve this 3.5 R value. So if we go for a brick bed cover, to achieve this kind of insulation value, we'll have to go for 3.1 meter thick layer. With brick, simple brick, it will be 2.36. With foam concrete, it will be 1 meter, 1.05 meter. With XPS board, it will be 102 mm. And with PU foam, it will be 63 mm. So 63 mm thick layer will achieve this R value. Whereas if you go for a mineral wool, we will have to go for a 140 mm thick layer of mineral wool to achieve this kind of R value. Similarly for wall, this 2.1 mm of R value, again 61 mm thick, it is 47, 48 mm of PU foam, whereas XPS is 61 mm. So it is clear that the K value of material, it plays a major role in designing of insulation system. The thickness, design of thickness, and selection of material plays a major role. So next slide, please. In our range of material, we have two kinds of material, two kinds of spray foams are there. The one is called blue seal system, which has a K value of this is spray PU foam, and it has a K value of 0.029, and this we normally market against brick bed cover in government buildings or commercial buildings, where brick bed cover is a specification, and brick bed cover is considered as an insulation layer also, but actually it is not an insulation layer. It is normally a sloping screed material, because it is when nothing was available, not much of insulation materials were available in past. These conventional systems were agreed because of a lot of air gap, because this structure, this system is slightly porous system. So by virtue of that, they give some insulation property. So this material is given to a thickness of around 20 mm and 15 to 20 mm, and they achieve the insulation property similar to brickbat coba of around 300 mm thick. The 300 mm thick brickbat coba, whatever insulation property is achieved, it is achieved with this 15 mm thick blue seal system. And these systems, they are directly sprayed on the RCC slab, and then above this RCC slab, this PU foam, there is a sealer coat, which also acts as a waterproofing layer, and then above that, a screed, concrete screed to slope is given, or brickbat cover can be taken for giving required slope to the rain outlet, for draining out the rainwater. Next slide, please. And the other version of this material is called foam shield, which has a higher thermal efficiency and better K value. They have a K value of 0.023, and to achieve a requirement of R value of 3.5. So this PU foam, it requires around 65 mm thick spray foam layer of 65 mm thick to achieve, and it will give the insulation property and insulation value, R value of 3.5. So in the side photographs, you must be seeing that it is being sprayed. It is either green or blue in color, light sky blue or very light green in color. So they are green material. They don't have polyisocyanide normally, which is there used in polyurethane foams material as an activator, but these are isocyanate free materials and green material. So next slide, please. So till now we have seen insulation on the roofs. Now there are materials available which are used for insulation on walls also. So they are also either in the form of coating, reflectance, which works on the reflectance, high SRA coating material, or there are materials which works on the conductance, so by reducing the heat transfer through conduction. So if you say in this photograph, we see that normally what kind of different blocks walls are there. So it is either single block wall with cement plaster on both the sides, or there are concrete wall with cement plaster, or there are single wall with ACP, aluminum composite panel on the surface, on the outer surface as a facade. Then there are cavity walls. Cavity walls systems are used for giving insulation. So there is air gap between two parallel walls, so to give insulation. Then these insulation systems are not that efficient. Now the present version of insulation system, which is called EIFS. This EIFS is exterior insulation and finishing system, and they are EPS based systems, extruded polystyrene board systems. So they are used as an exterior finish for giving insulation to the walls. Next slide, please. So if we say what kind of U value will be achieved in a brick wall, if we provide give a 75 mm thick EPS system, it will give a U value of around 0.346. And in AC blocks, if we give 50 mm thick EPS systems, because AC blocks they also give some insulation property because of air cavities in between. So it will achieve U value of around 0.335. And in concrete wall with 75 thick EPS system, the Eifs EPS system, it will achieve a U value of 0.35. So for these materials can be used for all kind of exterior finish systems, brick, AC blocks, or concrete walls. Next slide, please. So we in Pidilite, we have introduced this external insulation finishing systems in association with a company called Grupo Yuma from Spain. And this exterior finish system we have already installed in many structures all over India. In Delhi, the Mall of India, it is based on this exterior insulation system. And we are doing a large Amrita hospital in Faridabad with this exterior insulation finish systems. So next slide, please. So they look good. They give waterproofing as well as insulation property, and they aesthetically they look as if nothing is. They give a very good aesthetic finish also. So they don't look like it's something from outside is provided for insulation. It gives a very neat and clean finish and very good exterior finish. So how this system is installed, it is basically on the verging face of wall. Either it is brick wall, concrete wall, or AC block wall. There is a layer of adhesive mortar, first layer of adhesive mortar. Then these EPS boards are pasted on the wall. Then through mechanical fasteners, they are screwed into the wall. Then there is a reinforcing mesh spread on the exterior, and then a rendering finish, a rendering plaster is given. And this is also a high strength exterior plaster, which is given. And then they come in different finishes. They come in texture finishes, they come in different shade finishes, and you don't need to paint also. Next. So they achieve the required ECBC guideline U value requirement within the range of 60 to 75 thick exterior cladding. So next slide, please. So if we just understand what is achieved, what kind of advantages are achieved by giving these insulation systems on walls and roofs, we in next few slides we will see the energy modeling of a commercial building. Next slide, please. So here we are taking an example of building which is located in Delhi, and the shape of building is rectangular, 50 meter by 100 meter. Number of floors are 9. It is an institutional building, and the facing is south facing. 100 mm side, 100 meter side facing is south, and it will be used from 9 to 6. So as per ECBC guideline, we have seen a full day 24-hour use building or daytime use building. So the energy requirement will be based on that. So the occupancy will be 75 square feet per person. This is the because the how much habitants will consume, how much energy will be, it will all design calculation. We are just taking few clues from those design, because from those design model, because it is a very vast calculation. Then equipment will be equipment consumption will be 0.5 watt per square feet, lighting 1.45 watt per square feet. HVAC, it is air cooled chillers with COP. So COP is basically coefficient of performance, and this rating is 3.2. Then this AHU with variable air volume is being used in this building. Then variable speed fans will be used, and then this is the WWR. WWR is basically wall to window ratio. This is 20%. This 20% is the wall to window. Now, what percentage of surface window is covering? So this is that percentage. and the conditioned area is 4,84,423 square feet. The what we saw in the envelope photograph, the conditioned area where we need this complete cooling effect is 4,84,423 square. So next slide, please. So as per ECPC guideline, the roof should have U value of 0.33 and wall should have U value of 0.4. For achieving this, we are using polyurethane foams on the top surface roof and 65 mm thick and 75 mm thick EPS or for wall insulation. So we are achieving this ECBC requirement by using this PU foam and EPS, PU foam on roof and EPS on wall. So how we will conserve our energy and what will be the saving, we'll see in the next slide. So please, next slide. So this is all we have defined. This is the energy requirement. Energy requirement for interior lighting, equipments, cooling. For cooling, how much energy requirement is there? So total energy requirement is coming out to be 44,46,000, and total energy cost will be 1,20,11,200. So if we say the what kind of square feet per tonnage is there, so 387 is coming out, and ton rating required for cooling this building will be 1252. After this insulation, there will be no change in interior lighting consumption energy. Equipment consumption will not be there. No change will be there in that. They both are same, but the change will come in cooling, energy requirement in cooling, fans and pumps, which is used for this handling these cooling systems. So the total energy requirement is coming out to be 39,68,100, and energy electric cost will be 85,70,320. And if we check for the square feet ton rating, 548 square feet per ton it will cover. So the ton rating demand will be 890 as against 1252 ton rating demand for cooling this building will be in non-insulated structures. So what amount of ton rating saving is 362, the saving in ton rating, and saving in electrical consumption is 34,40,000 per annum. So next slide, please. So if we say that whatever investment we will put up in doing this, installing this insulation, the total insulation cost of providing this 65 mm thick PU foam and 75 mm thick EPS for around 5,000 square meter of roof surface area and 8,451 square meter of wall surface area is coming out to be 3 crores 85 lakhs 43,200. And per annum, per year, we are saving energy of 34 lakhs 40,880 rupees. So if we take through energy saving, we'll recover our investment done in insulation in 11 years. But if we check how much ton rating we have reduced, the ton rating is the initial installation demand of our cooling system. So there we saved 362 ton. We are cooling this structure with less amount of tonnage, refrigeration tonnage. So here we have saved 1 crore 81 lakhs rupees in ton rating. So by virtue of this, we will recover our amount in 5 years of almost 6 years. So this is how insulation is not an investment. It's not an expenditure. It is an investment. So next slide, please. So these systems were for exterior wall was systems which were based on conductance. We also have systems for exterior coating which are high SRI coating, which work on reflectance property. So these materials are under raincoat range. The lighter shade we get for raincoat. The raincoat are waterproofing come in exterior paint. They are finishing paints which have a property of waterproofing, as well as they have property of high reflectance also. So these range of materials are also available for exterior painting, which are high SRI coating. So by using that also, you can reduce the surface heat absorption through walls and get better insulation inside and better comfort inside the structures. So this is how there are different materials in different segments which help in giving your structure waterproofing as well as insulation property. So, and as a result, achieving heat-free and leak-free structures, so resulting to more durable and more sustainable structures. So this is all from my side. So Spaniel, you can open for question.
So in the beginning, we could not see many slides. If you can share this PPT or whatever, this PDF, it will be good for us.
So any questions from audience, they can unmute themselves and ask questions.
So I was telling that if you can share the PPT or the slides, whatever we are talking about, then it will be useful for us, because in the beginning we have not seen the PPTs, I mean slides.
So, could you share your PPT with us? We share with our participants.
पांडे मैम, आप कुछ बोल रहे हैं क्या? मुझे कुछ सुनाई नहीं दे रहा है अभी.
Sir, am I audible, sir? Am I audible, sir?
You are audible, ma'am. You are audible to us, but I don't know about him.
Okay, sir. Asthana, sir? Okay, we will ask for PPT. We will ask personally for PPT. We will share in the WhatsApp group.
If you can do it as soon as possible, it will be good for us.
Yes, sir.
Am I audible?
Yes, sir. Now you are audible, sir.
आपकी आवाज नहीं आ रही मुझे.
Hello, Asthana, sir. Asthana sir given permission to share the PPT with all participants. I will share the PPT with in WhatsApp group.
Please do it as soon as possible.
Okay, okay, sir.
Okay.
Sir, if you have any question, please ask Asthana sir.
You can put your messages in, you can put your question in message box also.
Okay,
can ask
if
and,
anyone
or
has
you can
any
put your
question,
question in
please
message box also.
please ask in chat box, please. Dr. Animul sir, if you have any question, please ask in chat box, please.
No question, ma'am. We need the PPT. That's it.
Okay, thank you, sir. Thank you. Okay, thank you, sir, for sharing your valuable time and knowledge. Could I close the session, sir? Asthana, sir? I think there's technical problem. He's not listening to us. Okay, now I'm closing this session. Thank you all.